Hi, in this series we're looking at creating geometrical shapes using custom meshes in Unity. In this episode we're going to be creating regular convex polygons from scratch. Let's get started. A regular polygon is an n-sided shape where all sides are the same length and the angles between them are the same. So this is going to be your equilateral triangle, square, pentagon, hexagon, etc. Let's focus on the pentagon. We're going to start with an empty script on an empty game object. For this, we're going to need three properties that we'll want to set for each polygon. We'll need a material so that you can see the rendered mesh, the radius, which defines the size of the polygon, and the number of sides or vertices, which defines the shape. For your purposes, you may wish to use the side length rather than the radius to define your polygon. For this, you can always convert them with the formula shown. This script is designed to be placed on an empty game object, so we'll have to add the required components ourselves. To do this in Unity, we're going to need a mesh filter to hold the mesh, and a mesh renderer so it can be rendered, and of course a mesh object for the mesh we're going to create. We assign the material and the mesh to the components we've just created. Even though we haven't populated the mesh object, there is no problem assigning it now. To create our mesh, the first thing we need is a list of the vertices. We're going to center the polygon at the origin and calculate each vertex starting with the point at the top, x equals 0, y equals the radius. And the angle we're going to move each time in radians is going to be 2 pi over the number of vertices in our polygon. But how do we know where the vertices will go? Well, every point on the circle can be represented as xc plus r sine theta for the x-coordinate and yc plus r cos theta for the y-coordinate, where xc, yc here would be our centre of the circle and r the radius. And theta is going to be the angle to the vertical y-axis. For us, the centre will always be at 0, 0, so this simplifies to r sine theta, r cos theta. And we can move the radius to be an outer multiplier so it looks much neater as r times sine theta cos theta. So as you can see in the code here, we've created an array of vertices and we're iterating through the points by incrementing the angle each time. We're creating the points in the xz plane. You can of course do them in a different plane if that makes more sense for your project. The ordering of the vertices doesn't matter, but for our triangles they need to be created clockwise in Unity, so that the normal points outwards in the way we expect. This is because triangles are only visible from one side. So by creating the vertices in this order, this will make the next part easier for us. There are two natural ways to triangulate a regular polygon. The first is to have an extra vertex in the centre, then create the triangles from this going around. However, this creates more triangles than strictly necessary, and often we want to minimise the number of triangles. The second way is to create each triangle starting from the same point on the edge. So starting at the top point here, we create triangles by moving around the circle as shown. This makes the code much neater also. In Unity, creating this list of points is done as an array of ints. These are processed 3 at a time to create each triangle. This is just one of Unity's quirks, rather than using the more natural implementation of perhaps an array of vector3 ints. As you can see from the code, this will create a triangle using the vertices 0, 1, 2, then 0, 2, 3, then 0, 3, 4, etc. So doing exactly as we want. And finally we have to add the triangle array to the mesh. In order to keep this short, I've excluded calculating the UV coordinates from this episode. If you're interested, in the second part of the series, I'll go back in and add that. As ever, the full code is linked in the description below, and I hope you found this information useful in some way. See you next time.